Good afternoon, Professor.
Hey, how are you?
Good, how are you?
Good, good. Nice, easy section today. It's only like 5 examples.
Awesome, yeah, because I really have to catch up on my homework. I've fallen behind.
The sooner you catch up, the better, because that end of term is always brutal. Just wait a few minutes for everybody to show up. So this is a short section that we have today, although it looks like a very long lesson. It'll take about just under an hour. And after that, you guys, I posted your quiz for chapter 3, and should be good to go from there.
And that closes Sunday?
No, I left it open. You have 3 attempts until August 3rd.
Okay, all right, thank you.
Mm-hmm. It's not 4 o'clock yet, is it?
No, it's just it's 3:59, so I guess
One more minute.
That's what I thought. So I'll start around 4 or so. Okay, very good. All right, so I'm going to get started with section 3.6. And this is, believe it or not, probably you'll find it as one of the easier of the sections that we've covered lately. In this section, the 5 examples I'm going to do, for the most part, are pretty quick and straightforward. So let me go ahead and get started. And then after that, we'll work on the homework and the quiz. For section 3.6. And so 3.6, we're basically looking at polynomials and rational functions. So we're looking at polynomial and rational functions. So I'm going to begin with example 1, and we'll go from examples 1 through 6. It's only 6 examples. I was kind of hoping to finish it in class, and I apologize for that, but time is time. I can't control it. Okay, so in example 1, we are solving a quadratic inequality. And that is the gist of this question. Basically, it means that you have a trinomial and you're going to solve for it. So they basically are asking you in the question stem, they say solve the inequality and this particular inequality has 3x times x minus 1 is greater than 10 minus 2x. This is what they start you with. And so quite simply, your first step is going to be, let's distribute this 3x on this side and solve. So we're going to have 3x squared minus 3x is greater than 10 minus 2x. And what we're going to do is we're going to move everything on the right-hand side of the equation over to the left. So I'm going to begin by subtracting 10 and adding the 2x on the right. And again, I'm going to add the 2x and bring over the 10 to the left. And the reason why I'm doing that is because basically I want this to be set to 0. So without having any overlap in terms, the 3x squared always goes first. This results in negative x right here, and then the negative 10. And technically now that's zero, greater than 0, or we could set it equal to 0 to solve. So if you feel comfortable with solving this inequality using, say, the AC method, or you can do guess and check, I would do the AC method. I like that method. So in case you have trouble with factoring, that is something you might want to work on. So the AC method, this is A, this is C, and the reason they call it the AC method is basically I have the number 30 and I'm looking for 2 factors that'll multiply it to be 30, but that are only 1 unit apart. So if you notice 6 and 5 works for me. So that means that I'm going to re-express this equation as 3x squared. Let's go with minus 6x because of this negative. So minus 6x plus 5x. And then obviously the minus 10 just gets dropped here, and that's greater than 0. So now since we have 4 terms, and these two definitely will come together to give me a negative 1x, which is what I wanted. We're going to do what's called factor by grouping. So I'm going to divide this equation exactly in half here. And I'm going to extract the like terms here, or the GCF here. So I'm going to take out a 3x, and this leaves me with x minus 2. If I do the same thing on this side, I'm looking at the 5 and the 10, and I'm thinking, well, if I take out a 5, that works. If I go with a plus 5 here, this will give me x minus 2, and that's what I want. Because these have to match. This has to match this. And the reason for that is that now I have 3x plus 5 as a binomial factor, and I have x minus 2 sitting here as well. Because remember, this is not a square, this is a distribution. Now, if I think of this in terms of 0, I can now solve for the values. Okay, so one of my values, if I take 3x plus 5 and I set it to 0, I'm going to subtract the 5 on both sides, leaving me 3x is equal to negative 5. And obviously I'll divide by 3 on both sides, leaving me my answer, which is x is equal to negative 5 over 3. And I'll repeat this process with the x minus 2 equal to 0, which is, this one's a little easier. I'll just add the 2 to both sides, and I'm left with x equals positive 2. Now, what you need to understand is now we need to draw an interval. So you literally are drawing a number line where this is negative infinity and this is positive infinity. And I am marking on a number line the equivalent of negative 5 over 3 and positive 2. And I'm going to test, in essence, 3 intervals. So my test points, the test points I'm going to do in red. And I have to determine if those test points actually are solution areas. So for example, between the negative and 5/3 and positive 2, there sits a 0. That's one of my first test points. 3 is a good use of a test point, as is, let's go with negative 2. And so if I try points such as this, now what I want to do is I want to go back into the equation, and according to the equation, my value or my solution to this equation has to be greater than 0. So it has to be a positive value. So if I plug in, let's say I start with negative 2, what I'd want to do is substitute that into the original equation. And so I could even use this equation, but technically speaking, once you divide this, notice that I have 3 intervals. So negative infinity, comma, negative 5/3. It's not inclusive, so because there's no equal to, so I'm not going to bother with that. We would say union. The secondary interval would which actually does work, which is possibly our 3. And just for the record, I know that 2 comma infinity does work. And so we would say our solution is from 2 comma infinity. Now, how I got there is what's important. So notice that I am going to start with f of negative 2. And for this to be inclusive, or to be one of my intervals that actually works, I would need this interval to be greater than 0. So just as an example, let's say I go back to this original here, and I start with 3 times negative 2 squared minus 2 minus 10. And then, so this is going to give me 3 times 4, and then this becomes plus 2 minus 10. So this is 12 plus 2, which is 14, minus 10, which is 4, and that is definitely greater than 0. And that is why I know that that works. I'll do the same thing with the 3. If I do 3 times 3 squared minus 3 minus 10, is that greater than 0? That's the question that we're going to answer. So obviously this gives me 9. 3 times 9, 27, and I have 27 minus 13, which gives me positive 14, and that is definitely greater than 0. So that's why this is my other winner in terms of intervals. The reason why I reject the interval, which is negative 5/3, comma 2, is that 0 is my test point there. And so 3 times 0 squared minus 0 minus 10 is not greater than 0, because negative 10 is a negative number, and a negative number is never greater than 0. So this is not acceptable as a region. So you'll have to do that every time you have a question that's asking you to solve a quadratic inequality, because with the inequality, you have to understand that you're trying to fulfill whether or not the greater than, less than, equal to all play a role. Now, do remember that in this case, we are dealing with not inclusive. So these are all while this does say with the -5/3 and the 2 are used, they're not part of the solution. If we throw them into the solution, it'll create a 0 and therefore make this null and void. Okay, more of the same. So this is not really a new example, but it is called example 2. And they basically are asking you to solve the inequality. And they're giving us x to the 4th power minus 12x is greater than or equal to. So this is inclusive, so we will be using brackets. And on the right-hand side, we have 8x squared minus x cubed. And so the first step I want to take is I want to move anything that's on the right-hand side over to the left. So I'm going to subtract 8x squared, and I'm going to add x cubed. I'm going to subtract 8x squared, and I'm going to add x cubed on the left-hand side. So all of these cancel because they're the same. We end up with x to the 4th plus x to the 3rd minus 8x to the 2nd minus 12x is greater than or equal to 0. Okay, and now we can use factor by grouping, which is recommended. So the first thing I'm thinking is they all have x's. Maybe I can start by extracting an x. When I do that, I'll get x to the 3rd plus x to the 2nd minus 8x minus 12, and all of that is greater than or equal to 0. All right. Now, I'm looking at this and I'm wondering if we do factor by grouping. So let's try that first and see if it works. So disregard this little x, just put it over here for the moment. We're going to focus on just this part. So notice this is going to give us x squared plus x. And so I can already tell, actually, no, my apologies. Hang on a second. We're actually going to take out x squared, which gives me x plus 1. So I'm looking over here at this 8 and this 12, and I'm thinking, well, only the 4 is unique. So maybe that is not something that I want to do. Because even if I took out a 4, I would end up with a 3 or a 2, some other number out here, and I'm not going to get a matching x plus 1 on this side. So that factor by grouping is not going to work here. So now I have to use my reasoning. So we have, in this case, to maybe do some division. I'm thinking if I use synthetic division that we could narrow down some factors. So positive, since the coefficient here is 1, I'm thinking some possible zeros are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Because what we're doing is we're looking at the 12, which is this term right here, and the coefficient 1, which is why, if you notice, I haven't really bothered with the division part, because basically I'm dividing by plus and minus 1. Who cares? So all factors of 12 are up here, and all factors of 1 are down here. 1 is a very easy number to work with. Obviously, it's an identity, so I don't need to worry. Just focus on the coefficients of 12. So let's use, let's go with, I'm going to just throw a number out here. Now, you technically, I know it's not 1, and I can tell you it's not 2, so let's try at least 3. And if you notice, I'm using the coefficients 1, 1, -8, and -12. So 1, 1, -8, -12. This is synthetic division. I don't know if you remember this. Synthetic division. And here's what's going to happen. In your case, for most of you, you're going to start with plus or minus 1 and plus or minus 2. So it's going to take you a little bit of time to get to the solution. The only reason I know it's 3, it's because I can tell based on the schemata of the numbers that should work from experience. So remember that to do synthetic division, you drop the first coefficient, and now we multiply here. 3 times 1, that gives me 3, and I add going this way, which is 4. 3 times 4, well, that's 12. 8, -8 and 12 leaves me another 4. And my last multiplication here, 3 times 4, well, that's positive 12. Yep, I was right. You see how this is 0? That tells me that this is one of the divisors. I've already got an x, so I've got an x. I've got an x minus 3, which is basically the opposite sign of that number there. And I'm left with, now these coefficients are now x squared plus 4x plus 4. Okay, so these drop. Remember, this originally is an x to the 3, but you technically are dividing by an x, and this is actually x squared, x, and x1 and x0, which means that's now the new constant. So as I look at that, I know that this is an x plus 2 squared, and that goes with special products. So my factors for this are x, x minus 3, and x plus 2 squared, which means that my solutions are x is 0, that's this value here, x is equal to positive 3, and x is equal to negative 2. Because remember, this is just simply x plus 2 times x plus 2, which I can solve for both of those and set them to 0, and I get those numbers. So now I have 3 values, and I'm going to check on that number line. So if this is negative infinity, this is positive infinity, here's 0. I've got a 3, and I've got a negative 2. Now I need to find some test points. Again, my test points are going to be in red. So let's use negative 3 for a test point. Let's use negative 1 for a test point. Let's use 1 for a test point, and let's use 4 for a test point. I'm choosing numbers that are really friendly. So in this case, as I look at my intervals, I have 4 intervals to check. So let's start with the negative 3. And according to this, my value, according to the original equation, this has to be positive or equal to 0 to be true. So if I start here with f of negative 3, this is going to give me 18, and this is plugging it into the equation. 18 is a value that is greater than 0, so that is good. Okay, let's do f of negative 1. You plug that into the original equation, so I'm just doing some mental math. So just for the record, let me back up so you can understand. I'm basically doing math. Sometimes knowing the information makes teaching sometimes a little difficult because you forget to just relax. So this is basically 81 minus 27 minus 72 plus 36. And therefore a number greater than or equal to 0, because this together is negative 99. And this together okay, sorry about that, I had a little interruption. Okay, and then 81 plus 36 puts me at 117. So 117 minus 99 is 18. That's where I'm getting f of negative 3. And I repeat this for f of negative 1. I'll do this for f of 1, and I'll do this for f of 4. Basically just plugging it into each equation and solving. And so in doing so, we arrive at our varied answers. So let's see. All right, so f of negative 1 is also a value that will be greater than 0. I'm going to end up with 4. So again, just doing the math in my head. So this will give you 4. So we're good. This is not going to work. Believe it or not, the 1 is going to give you a negative number. And at this point, I don't even care about the actual value of the number. I just want to know if it's positive or negative. This is definitely positive. This will give you a huge number. I believe this is going to come close to, if not 144. So that's good. So when we stop and we actually look at the solution, we would say that in this case we have from negative infinity because this was good, we would say comma 0 inclusive union, and then we dismiss the 1 interval because that gave us a negative number. That was no good. This is inclusive of the 3 all the way up to positive infinity. So this is good. And so again, we're using this equation as we're plugging in the numbers to solve. And that being our solution for that one. So, all right. I think for that, you need a lot of number sense and practice. So that goes back to your foundation skills. Okay, example 3. Here we're basically solving inequalities. And so for part A, we have 4x squared minus 12x plus 9 less than 0. In essence, if you look at this, the front number and the last number, they're both perfect squares. This is actually one of those special products. And if I solve for this, I'm going to end up with 2x minus 3 times 2x minus 3 as a FOIL, which means that this is 2x minus 3 squared. And according to this has to be less than 0. But if I solve for either of these, I'm going to get x is equal to positive 3 over 2. So there is no solution for this one in terms of its actual coefficient. Okay, for part B, if I solve for this one, I have been given 4x squared minus 12x plus 9. This one is less than or equal to 0. And so for this one, even though it's going to factor out the same way, because it's also equal to 0, the solution set will be 3 over 2. just like the prior one. The difference is in part B, it can be 0. Now look at this next one. It's the same function. You have 4x squared minus 12x plus 9, but this time these values are greater than 0. And so if I have 2x minus 3 squared, which is basically 2x minus 3 times 2x minus 3, and the values have to be greater than 0, then x is a value which is positive, and it is obviously greater than 0. So the solution set for this actually would be negative infinity, comma, 3 over 2, union the 3 over 2, comma, positive infinity. And that is because it's set to greater than 0. For part D, this is the same thing. Now this one is varies because even though it's the same function, its value is greater than or equal to 0. The equal to makes a difference because now the solution set of 2x minus 3 squared has to be greater than or equal to 0. So therefore x, the solution set for x is actually from negative infinity to positive infinity. It's all real numbers. So this is an evaluation question. There's the best way to understand this is stop and look at the solution and then watch the video, listen to my voice, and there you go. Okay, now example 4. In example 4, we are dealing with solving a rational inequality. They're giving you 4x minus 5 over x minus 2. Remember, a rational inequality, rational refers to anything that can be written as a fraction. So this is a fraction, basically, and it's less than or equal to 3. So step 1 in solving a question like this is to subtract the 3 and bring it over. So you really have 4x minus 5 over x minus 2 minus 3 over 1. But remember that to make this true, you have to multiply top and bottom by x minus 2 to build up this equation. So now you have a new equation, which reads 4x minus 5 minus 3 parentheses x minus 2. And all of this is over x minus 2. And no, you do not simplify it. Now, this is still less than or equal to 0 now at this point. So let's work this out. Distribute the 3, and this becomes 4x minus 5. And this is minus 3x minus 6, which once I distribute the negative, this becomes, and again, this is still continuing. This becomes 4x minus 5 minus 3x plus 6. And all of this is over x minus 2. And again, less than or equal to 0. If we combine our like terms, I have a 4x minus 3x, which is just x, and then plus 1, right? Hence the 6 minus 5 over x minus 2. And this has to be less than or equal to 0. So if I think about it, in terms of the numerator, x equals negative 1 and x equals positive 2 are boundary points, because this can never be 0, so that can never be 2. And for this to be equal to 0, this would have to be negative 1. And so now if I look at my number line, if I focus on the number line, Remember, if I have -1, here's 0, that'll be a test point, and here's 1, here's 2. So I'll do my test points this time in the light blue. I like using 0. I'll use 3, and I'll use -2. All right, and so this is very helpful if I go back to my equation. And so if I use f of -2 as a test point, I get 1/4, which is definitely greater than 0. So this is a rejection. If I do f of let's use 1, let's go with 1. F of 1, then this becomes -2. Okay, and if I use f of 3, again, I'm plugging it into this equation. If I use f of 3, well, this gives me 4. So it looks like I only have one solution set that works, which is inclusive of -1 to 2. Those are the only ones that work, which is this right here, from here to here. If you recall, our directional hypothesis means that this has to be a negative number, and we're looking at less than or equal to 0. So that's the winner, winner, chicken dinner right there. So this interval works. If you notice, the 2 is not inclusive, and that's because of the denominator. And so that is the only reason why the 2 is not inclusive. If that were not necessarily x minus 2 in the denominator, then I could use that, incorporate that as a inclusive, but no. Okay, example 5. More of the same. They're asking us to solve. And so they're just basically telling us, hey, I've got an x squared over x squared plus 1 or plus 4. And I've got several scenarios. I've got it where this is greater than or equal to 0. That's part A. In part B, same equation. I've got x squared over x squared plus 4, but this time I want it to just be greater than 0. And then for C, I've got x squared over x squared plus 4, and that's less than or equal to 0. And then for part D, I've got x squared over x squared plus 4, and that's less than 0. And so what you'd want to do here is basically solve for 0. And you find that as you solve for this, it'll start to connect for you as you play with the numbers. We know that at x equal to 0, this is positive for all values. And so we're going to look for, in this case, a solution set, which is -infinity to +infinity, because if we want that to be positive, that'll work for all. Whereas for B, we have to incorporate, in this case, not equal to 0. And so the solution would be from -infinity to 0, union from 0 to negative or to +infinity. Again, you're just testing points and using common sense. Here, if I'm less than or equal to 0, then my solution set would just be 0. Think about it. I could be equal to 0 or less than 0. Nothing is going to work other than 0 itself. And then the last point, it's just less than 0, not even equal to 0, in which case you would have to have an empty set. All right. And that would have to be the if you look at the graph of this thing, by the way, it kind of looks like, and you'll understand it as you look at the graph. This is branching out in both directions, just like a square root. So it kind of looks like that. And so it's also lined here at y is 1. And so you'll understand why these values play out the way they do. So this is an analysis. You have to analyze this and sort of internalize it. Okay, so analyze and internalize the solution set. Okay, the next question has to do with actually the application question. And this is the last example for this section, which is the toy rocket. And it's a real life application. And so this is what they tell you, basically. A toy rocket is shot straight upward from a launch pad one foot above ground level with an initial velocity which, by the way, initial velocity as notation is usually v0. And so in this case, a v0 is equal to 64 feet per second. And so the first thing they ask you to do is to write a model to express the vertical position. And so understand that in this case, we use a function which is s of t. And this is given to you. This is not something you would know off the top of your head. Is equal to 1/2 of g of t squared plus that initial velocity times time, and the constant given to you as 1 foot, which is the where it's shot from. So we would have 1/2 of 32. In this case, 32 times t squared plus the 64 times t as stated in the question plus 1. Now, I need you to understand a variable which I did not disclose to you. So this is given, by the way. So again, this is given to you. Nobody's asking you to come up with that. The variable g I didn't disclose to you. This is the acceleration due to gravity. And they actually tell you in this case that it is 32 feet per second. So, and this is square seconds. They say this is, or it's 9.8 meters per second squared. So t, time and travel, I figured you got that one. So t, your t is time of travel. And again, v sub 0 is initial velocity. And s sub 0 is the initial vertical position. So initial vertical position. This is all given to you, so it's not something we expect you to come up with. but we do want you to use the equation, basically substitute as you read. All right, and if you're having trouble following some of this, let me highlight some details. That's your initial velocity. This is your 1 foot above the ground level. That's your S of 0. And this part was given to you in the setup. All right, so anywho, so once you plug this in, you would work this out. So you find that S of t, which is what we're looking for, is equal to negative 16 t squared plus 64t, and then plus 1. That's all they're asking you to do there. Then for part B, this is all part A, by the way. In part B, they're asking you to solve or determine the times, basically. Determine the times at which the rocket is above a height of 50 feet. So since they want above 50 feet, what we want to do is we want to take our equation, negative 16t squared plus 64t plus 1, and we want to make it greater than 50. And then at this point, it's basically algebra. My suggestion is after you move this, you get negative 16t squared plus 64t, and then minus 49. And this is now greater than 0, so we want it positive. And we would use the quadratic method. Use the quadratic method or the quadratic formula to solve for the values. You should end up, and just for the math purposes, remember that A in this case is negative 16 and B is going to be 64, and the C value is equal to negative 49. So if we do the quadratic method, we will get time t is equal to negative 64 plus and minus the square root of 64 squared minus 4 times negative 16 times negative 49. And all of this is over 2a, which will be 2 times negative 16. When you solve for this, you're going to get t is equal to 8 plus or minus the square root of 15, and all of that over 4. So when you do the math here, your two solutions are going to be approximately 2.97 and 1.03. And just like the other examples, you're going to create a number line. You have your two cutoffs, which is the 1.03, and you have the 2.97. So if I were to select some test points, again in red, so let's say one of my test points is 1. Let's use 2, which is the number between those two, and let's use 3. Remember, this is negative infinity. Again, this is positive infinity. And so if we're solving for both of those cutoffs, we find that f of 1 is going to be less than 0. And so we're looking for values where it's above the ground, so we want greater than 0, we want positive. So this is a refusal. F of 3, well, that's going to give us a negative number. So this is also less than 0. This is refused. But f of 2 happens to give us value of 15 when we throw it into the equation, and therefore greater than 0, and therefore this is a winner. And so our interval is going to sit in between those two values. So we would say 8 minus square root 15 over 4, not inclusive, comma, 8 plus square root 15 over 4. Okay, now the chances of you getting a question like this on a quiz or test are like nil. So it's just so you see the application of this concept. So I'm going to go ahead and stop the recording. Okay. Not too bad. Your homework is open. Go ahead and get started. And so is your quiz. I'm here if you need me.